Okay, so now we're on 9-3 rotations. So we've already talked about reflection, translation, and now we're on rotation. So the first time first time I talked to you guys about this, I did, I guess, basketball. So a translation is a slide, right? So when you have basketball, you're sliding, right? I'm just going like this way, right? When you have a rotation, I wish I had my other mic on a mic. When you have a rotation, you're pivoting, right? You got to keep your foot down. So how far am I rotating now? 180. I did a full, like you saw my front and you saw my back, that's 180. How far now? 90. A different way, but that's fine. So did I change size or shape? No, I didn't, right? I can't just turn around. So a rotation doesn't change size or shape either, but it obviously rotates. Typically, in this class, we will rotate about the origin. You don't have to, but typically that's an easy one where we have a rule, okay? So if you look, a rotation is a turn around a fixed point, like I just did, called the center of rotation. Typically, like I said, we do about the origin, doesn't have to. So angle of rotation, the measurement to turn. So if we do 90 degrees counterclockwise, 180 counterclockwise, 270 counterclockwise. First of all, we need to understand clockwise, right? So if you look, I have a clock up there on purpose. I have that kind, so that way, if you ever forget which way to go, you look at the clock. So here's clockwise, in case you don't know, okay? And then here's counterclockwise, in case you don't know, okay? So we're going to do counterclockwise. Those are the ones we have rules for. However, isn't 90 degrees, well, I'll do it this way. Isn't 180 counterclockwise the same as 180 clockwise? Either way, it's 180, right? So isn't 90 degrees, let's say, counterclockwise the same as 270 clockwise? Because the circle's 360. Do you see what I'm saying? So if they don't ask you a counterclockwise question, typically you can work backwards and figure out the rule that way. Okay? So 90 degrees counterclockwise about the origin. If you start with x comma y, like 2 comma 1, okay, you're going to flip the order and take the opposite sign of the original y. For example, if you like examples, if I have 2 comma 1, it's going to turn into -1 comma 2. Do you guys understand how I flipped the order and I took the opposite sign of the original y? Is that okay? Those are actually really hard to kind of figure out on your own, so the rules are super helpful. If you're typically a geometric person, you're going to want to be algebraic for these, okay? So again, on 180, if I start with a 2 comma 1, I don't flip the order, but both signs do change. So this is now -2, -1. Is that okay? 270 counterclockwise, if I start with 2 comma 1, it's going to turn into, what do you guys think? 1 comma -2. Very good. Do you guys get that? Okay. On number 15, it says graph each figure and its image after the specified rotation about the origin. So you're going to graph rhombus WXYZ if you haven't already. Make sure you label them. And we're going to rotate it. It just said 90 degrees, so I want you guys to go ahead and write down counterclockwise. If it doesn't specify, we're going to do counterclockwise because that's what we have a rule for. Okay? So if you already graphed it, great. Just hang on for a second and I will too. So -3, 4, W, 0, 7, 7 is X, 1, 2, 3, 1, 2, 4, Y, and 0, 1. Be careful with your 0, 1. People get that wrong a lot, so make sure you graph that in the correct location. Okay? So again, the rule for 90 degrees counterclockwise is X comma Y turns into what? -Y comma X. You don't have to write that down. It's right above yours, but for me, I can't see it. Okay? So if I look at this one, -3 comma 4, what's that going to turn into? -4 comma -3. Does everybody understand that? They flip places and you take the opposite of the original y. So 0, 7, let's flip places. That's going to be 7, 0, and take the opposite of the original y. So what's it going to be? -7, 0. Super easy, right? What about y prime? -4, 3. Very good. Z prime? -1, 0. If, for instance, the 0 was the one we were supposed to take the negative of, what would we write? It's just 0, right? We don't write -0. That's weird. Okay, so let's go ahead and graph those and label them. So -4, -3 is going to be left 4, down 3, W prime. -7, 0, 1, 2, 3, 4, 5, 6, 7. I think I can't see that. Yeah. X prime, -4, 3, 3, Y prime, and -1, 0, Z prime. So again, be careful with your zeros. A lot of people tend to mess those up still. So here's what I want you to see. What is each quadrant? How many degrees is each quadrant? If there's 4 quadrants and they make up 360, each quadrant is 90, right? So if you were in quadrant 1, for example, totally in quadrant 1, and they have a 90-degree rotation, you're going to end up in quadrant 2, right? So here I'm halfway between quadrant 1 and quadrant 2, so 90 degrees better be halfway between 2 and 3. Does that make sense to you? Okay. If you're in quadrant 1 and you have a 90-degree counterclockwise rotation and you tell me it's over here, you did something wrong. Okay? And also pay attention to see how the X started up here and it rotated down here. So with the translation, that wouldn't have happened. With the rotation, it literally rotated about the origin, about 0, 0. Anybody confused at all? Okay. On this one, go ahead and graph triangle JKL if you haven't already. So 3, -7, 2, 3, 1, 2, 3, 5, 6, 7, I think. J. 1, -1 is K. 5, -3, 1, 2, 3, 4, 5, 1, 2, 3, L. All right, so there's JKL. Again, the rule, we don't do AB, sorry, we do XY, right? What's it turn into? What's the rule for 270 counterclockwise? Yeah, y -X. Okay? So for J prime, we're going to flip them around. So it's going to turn into -7, 3, and then I change the value on the original X. So -7, comma, -3. Is that okay? All right, what do I get for K prime? -1, -1. L prime? -3, -5. Is that hard for anybody? Is everybody following that okay? Okay. So -7, -3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Make sure you label. Oh, J prime. -1, -1. K prime. And -3, -5. 1, 2, 3. 1, 2, 3, 4, 5. L prime. So there's my new triangle, but I do want to kind of look, oh man, I do kind of want to look it over. If you look at this 270 degrees, if I'm in quadrant 4, I should hit 90, 180, 270. I should be in quadrant 3. That's right. Okay. And then if you look at the way it rotated, K still stayed here because it rotated here. And then the L rotated here and the J rotated here. So that's a rotation. That is not a translation. Did I lose anybody? Is it as easy as I think it is? Okay. All right. This one is 180-degree rotation. So what's your rule this time? X comma Y goes to what? Negative X, negative Y. Good. So why don't you guys, we'll do W prime together, and then I'll have you try one by yourself. Negative X, negative Y, W prime. So -6, 3 is going to turn into 6, -3. So why don't you guys try the rest of them while I graph the original, and then we'll graph them together. What did you guys get for X prime? 5, 3. Very good. Y prime? 1, 3. Z prime? 2, -3. Is that confusing for anybody? Okay, when we graph it, we have to label these. I'll show you why that's so important in just a second. So write 6, 1, 2, 3, 4, 5, 6. Down 3, 1, 2, 3. W prime, 5, 1, 2, 3. x prime 1, 1, 2, 3, y prime, I was thinking of z, 2, negative 3, z prime. Okay, how far were we supposed to rotate this one? 180. So that makes sense, right? If I'm here, half a circle away should be here. But if you look at this, if I didn't label these, what would this look like it was? Instead of a rotation, it could have looked like a translation probably, like a slide, okay? But because I labeled it, W started here and ended up down here. That's a rotation. Does that make sense? Okay? Have I lost anybody at all? Super easy. Skip number 8 on your homework. Skip number 8. Okay?